Hello, everybody. Welcome to WunderGraph AMA Special Edition Launch Week. Today, we have a very special guest, Michael Staib. Michael is the author of the Hot Chocolate Project, a platform for building a GraphQL server and clients in .NET. For his last 3 years, this open source project has been his main focus. And apart from his amazing work in the open source community, he also works as a consultant to help companies move on to GraphQL. Michael, thank you so much for joining us. How are you today?
Hi, I'm great. How are you guys?
Doing good. It's launch week. We're excited. We have a lot to talk about today. And, with GraphQL-Fusion and GraphQL-Conf coming, there's just so much energy in the air for the GraphQL ecosystem. So we're ecstatic. So once again, thank you again for joining us. I'm joined by my co-host, and he likes to joke around, the co-founder of me, Jens. Jens, how you doing today?
Hi, Stefan.
Typical. Okay, great. Well, Michael, again, thank you so much for joining us. Today, we're just going to keep it open. We're going to talk about GraphQL-Fusion. We're going to talk about your background. We're going to talk about GraphQL-Conf. Just all GraphQL, I guess, today. So to start it off, let's start with your background, Michael.
Yeah, so I'm a software engineer and did a lot of consulting work in the past. And at some point, when Facebook released actually the open source specification for GraphQL, I had a project where I was in charge to figure out what GraphQL is. And that's when I built a GraphQL implementation. And since then, I'm in the GraphQL ecosystem. And nowadays I have become a GraphQL TC, so I'm working on the technical steering committee and trying to broaden GraphQL and also help the specification to iterate.
Very cool. And so currently you work full-time as a consultant as well as co-founder of Chili Cream. So tell me about Chili Cream.
So Chili Cream is a company that we basically started last year. Or it's almost 1.5 years old. And it's basically our way to make the open source work that we do more sustainable. So while we all love open source, nobody likes to just sponsor a project. So we founded Chili Cream, which helps companies adopt GraphQL, helps them bring up the projects, does workshops and all these kinds of things.
Amazing. And that's interesting what you said, that open source is very tough. People love it, they love to use it, but when it comes to paying for it or sponsoring it, that's when it starts to get a little bit tricky. And one of the best examples I can think of is WinRAR. If you remember that zip file software, it's like, did you ever pay for that? No. But did it help you out? Yes. Amazing. And so with Chili Cream, I don't know if our viewers have seen it, but there was a very exciting announcement that we released about 2 weeks ago. So let's talk about GraphQL-Fusion. I'm going to link it in the comments as well.
Yeah, so GraphQL-Fusion is a new specification that we are working on. We started about almost 8 months ago together with Guild on that, actually. Back in Paris at the API days, we met as 2 companies and we were starting to talk that we all are trying to create a new open source product to handle distributed GraphQL setups. There was also an attempt to do that in the GraphQL Foundation, but as good as the GraphQL Foundation is iterating on a spec text that exists, like the GraphQL spec was written by Facebook, sponsored to the GraphQL Foundation, and it's easy to iterate in the group. It is quite challenging to create a spec text from the base level. So in a big group, as you might think, it can be quite chaotic to get to a full spec text that describes distributed GraphQL. So what we decided between the Guild and Chili Cream is to create a base spec draft and also an implementation and tooling and stuff around that, and then sponsor that back to the GraphQL Foundation. And that step is at the moment happening in the GraphQL Foundation. We are at the moment voting on it. The TSCs are voting to pick up this spec text into their responsibility.
Amazing.
So Sorry. Should I explain a bit what distributed GraphQL is? So
I
typically,
was going to ask that, yes.
typically when we talk about distributed GraphQL, many people don't really know what it is about. Is it about microservices? Is it about chopping down monoliths and stuff like that? So when we talk about distributed GraphQL, it's a bit anchored in history. Like if we look at the development in GraphQL, then people picked it up fairly quickly in the JavaScript ecosystem. And this had to do with the capability of GraphQL to have this single unified API and basically wrap it around existing infrastructure. Like you could have had a whole set of REST services, gRPC services, or whatever, and use GraphQL kind of as a gateway technology. And suddenly you had this great API experience for your front-end engineers, and you hid behind that all the complexities of your backend infrastructure. It's kind of like a compensation for this microservice approach where developers just went on and made the smallest possible services, and the consumers of these APIs had to figure out how this actually works together, which service to invoke for which. And now you had this amazing API specification that allowed you to consume this data, and behind that was the handling of these subgraph systems. And that's where distributed GraphQL comes in to formalize that and give us a solution to basically have a plug-and-play solution where you write these subgraphs, smaller GraphQL servers or OpenAPI servers or gRPC servers, and then Fusion comes in and takes all these and composes them into a single GraphQL server. And that is done from the subgraph level. So you can distribute the configuration over this to the teams managing this little microservice.
Okay, fascinating. And what was, when you guys met, it was API days, correct, in Paris?
Yeah.
How did that conversation come? Did you and Yuri were just hanging out? Did you guys grab a beer? Did it come over, a couple beers? How did that conversation sprout? Because I'm always interested in how good ideas come to Fusion, I guess.
Yeah. So the guild and JCream, like we as two open source groups, always had a good relationship. That means when we met somewhere, we would just talk with each other. And this basically was what we did there. So we had a couple of beers. We were out for lunch. And so we just got talking about what are you guys doing at the moment and things like that. So it's not that we met the guild for the first time there. They also we visit each other's user groups in between. So we knew already each other. And then this is basically if you meet as two groups, it's always a good chance to come up with new ideas.
I love that. And I think Jens can touch upon that, like the power of collaboration versus, when everyone's trying to do their own thing. And so today we launched Open Federation. And so Jens, if you want to touch upon that and then how it relates to GraphQL-Fusion, I'd love to hear that.
Yeah. There's one thing I would like to ask about Fusion, because so we can come back to the other topic later, but Fusion, or the idea of composing services together, it's not new. There's I don't know how many gateways or systems that do similar things, and they have various configurations and various ways of composing services. Like there's so many different approaches, or where companies try different ways of accomplishing this same problem. What makes Fusion different, and why will Fusion succeed or be something of value? Or what makes Fusion different in that regard?
There are a couple of things. So first, we embrace the GraphQL ecosystem. That means, like if we look at other solutions, often they introduce like things into the subgraphs that you have to fulfill. Like, for instance, the Apollo Federation specification. There we have a subgraph protocol. There we have this entities field, and you turn up, for instance, building subgraphs that you wouldn't build to expose publicly. And you're not really taking full advantage of GraphQL anymore. You're trying to fulfill this protocol. This has this is one of the downsides. The other downside is you always have to keep up. Like every time you change something in the router protocol, you have to update your subgraphs. They have to support that. So if your subgraph, for instance, only supports Federation 1, then you cannot take advantage of Federation 2 capabilities. And in Federation 2, we also have like a lot of iterations on this. Like Fusion doesn't need that because Fusion takes advantage of GraphQL as a specification, means it understands GraphQL as it was meant, and takes also advantage of the patterns that we have in GraphQL, like the relay patterns, for instance, things like that. Also on this side, like if we have these specialized protocols, often things like the node pattern is a difficult protocol to implement for these things because you have partitioning actually in there and things like that. This is where we thought we want to do GraphQL, and that means we need to embrace these patterns and practices. And for instance, if you just follow these patterns and practices, then you have zero configuration with Fusion. Just put your graph in there, and we will figure that out in the composition. And that is also done at build time. That means it's guaranteed that when we compose your graph from this, that it will work in any situation at runtime. There will be no surprise that it doesn't, that you have a query that suddenly leads to a disaster.
Is that possible with Federation?
Yeah, I mean, Federation does both runtime and they used to just do runtime composition, but nowadays they also do build time composition.
Okay. So go ahead.
Yeah, there are other things in Fusion that are unique. Like, for instance, that we also can compose third-party APIs, like Open API specification. We call these the adapter specifications. And also all GraphQL features are supported, like subscriptions in multiple variants, like live queries, like deferred stream, or like client-controlled nullability.
Can you subscribe to multiple root fields?
That is not allowed by the GraphQL specification, and that's what we follow in the end. Like the GraphQL specification says, you can only have a single subscription field, but what we can do in Fusion is like merging subscriptions. So one outer subscription can actually subscribe to multiple subgraphs and merge these events into one event to the outside.
Interesting.
And the whole configuration of all of this works through directives.
Depends. You don't have, as I said, if you follow the best practice in GraphQL, you don't have to have any directives.
Okay.
So you basically, for instance, if you implement the node pattern, what comes with this logic is that you basically have already an entity resolver. Like if we talk Federation, we have these. This entities field is actually a way to fetch entity parts by a key combination. If you, for instance, implement the node pattern, actually you have that already. There's a specified way how keys work, and there's a specified way how to fetch these things. And with that comes semantic understanding. And Fusion is a lot about semantic understanding of the subgraphs, meaning that if we know, like, there's a node, and you implement node on a subgraph, then we know you can resolve this particular information by key, and we can merge them on the on the gateway. There are other things like it could be that you don't follow the specification, and in this case, you can use directives. Like there is, we can annotate, okay, actually, this field semantically is the same as this field, and from this we can build the same semantical information.
Yeah.
But one of the things is that you don't have to pollute your subgraph actually with it. You can just add an additional GraphQL file and use the extension semantic of the GraphQL specification, right? You can just say, I'm extending here the query type and I'm adding this metadata to my field that I have in my service there. And then in the schema composition, we compile that and we can then understand the semantic connections between subgraphs and types.
Does it mean that Fusion has a bit more of implicit logic or things that you need to know? Like looking at your blog post, for example, there was one example, you have like products by SKU. So there's some semantics in naming things, and it is very important that you name it like this so that Fusion understands how it works. Is that something that can complicate adoption because you need to understand these little things, or what do you think about this?
So this is a variant in the composition. So as I said, if you follow these things, then you don't need to configure anything. And what I found is if you're doing GraphQL right, this is always a high horse, right? To say you're doing that right. But if you're doing a GraphQL in a certain way that is established, then we just understand how these things come together. But you don't have to follow this. You can, and I also outlined that in the blog post, you can completely say, I'm building my GraphQL in a complete non-best practice way. And then I tell you explicitly how to configure these things. And then we can build that model as well.
Okay.
So you can even go further. Like there is the resolve. There are a couple of directives in there where you can be very, very explicit. And it's basically up to you to decide if you want a way where you follow best practices and you don't have to do these configurations, or you can opt into say, okay, I don't want any inference. I even disable it, and I just go with the full explicit way.
Yeah.
Both is possible.
Okay.
When we look at the components of Fusion, it's basically that we decided to specify certain things in that process. And that is important also to give like vendors a lot of space to bring their own ideas in. Like we don't want to kill competition with a single thing that always has to work like this on every platform. It's more like we defined the guardrails, like for instance, how does schema composition work? And how do we get to a Fusion graph? The Fusion graph is basically the input into a gateway. So the Fusion graph document is very, very explicit. Everything is very explicitly lined out there. And if we feed that into a gateway, then the gateway should, if it implements Fusion right, be able to execute any query against that GraphQL schema, right? And its subgraphs. Mm-hmm. But what features you have in the composition is also up to you. You could decide as an implementer that you have additional inference or less inference, and maybe you just want to do explicit stuff. Maybe you have different directives even in your subgraphs that you want to support. Important is that piece of Fusion graph document, that this is compatible with each gateway. And this allows, like, also there to put different tools from different vendors in that bring different capabilities to that game.
And let's say a vendor, so Fusion is all around GraphQL, right? What if a vendor wants to add support for SOAP to Fusion. How is that possible?
Yes, like the guild is in the so with the guild we are working on OpenAPI at the moment. And what they basically do is introduce a translation layer into Fusion. So they have a little GraphQL translation layer to OpenAPI. And then the same composition works with these other technologies. So the core Fusion spec that we are trying to get under the GraphQL Foundation, that is concerned just with GraphQL. And then there are adapter specs like that bring in support for OpenAPI, for SOAP, for gRPC, things like that.
How can I, Stefan?
Go ahead, Jens. Go ahead.
How can I understand an adapter spec and what does it do? Like, does it just add more directives to my SDL, or where will this adapter run? Is that an external service like a sidecar, or is it part of the gateway? Or maybe you can help us understand a bit the architecture of such an adapter.
So that's a bit up to you, like how you do a gateway. Like the Hot Chocolate Fusion implementation, that is like our implementation of a Fusion gateway. We are actually running the OpenAPI adapter in the Fusion gateway. So the translation happens in the Fusion gateway, but that's our way to implement that. Could be that you decide that you want to run that in your own container somewhere else, or is up to the implementer. But such an adapter, if you want to get the raw gist of it, there is a specification done by IBM, and they also did an implementation for the Node ecosystem of how you could infer from an OpenAPI spec a GraphQL API. This GraphQL API basically to Fusion is just a standard GraphQL server. And you can use a standard Fusion API shaping directives. Like with Fusion, you can also reshape APIs. And we did that especially for the cases of these adapter specs, because like if you infer from a SOAP API, a GraphQL schema, that might not be the right structure that you want to have to get in your graphs. And this is where you kind of want to have these refactor directives to reshape it into a compatible subgraph to your overall gateway. Does that answer that a bit?
Yeah, I think that kind of answers it, and I think it is a very good idea to find this core spec. If we can find a number of vendors, obviously WunderGraph is interested, the guild is interested, Chile, hopefully others. If we can actually find some common ground here and get multiple vendors to agree to this core and actually implement such a gateway, I think there's an opportunity to create a whole new market. Like I saw this in the past with OpenAPI. I'm not sure if we would, because I worked for a couple of years for a company called Tyke Technologies. So they are like a full lifecycle API management solution. And what I learned in the API management space is kind of the space wouldn't really exist without OpenAPI, because OpenAPI gave all the vendors like Tyke, Kong, Apigee, and others a way of standardizing on what is a REST API and how can we treat it. And then you can build all sorts of tooling around serving OpenAPI APIs. And you can see how big the ecosystem is, how much variety, healthy competition you have, and how good the tooling became. If you look at GraphQL, I think as of today, we don't have enough competition. It is kind of, you have kind of siloed solutions. Like you have something like in terms of composition, like WunderGraph has a solution, Mesh has a solution, Atlassian has a solution. Everybody has kind of built their own island. And I think if we can somehow standardize this to at least to a core part, it's a huge opportunity to create a new ecosystem of API composition for GraphQL. And I'd love to hear your take.
Yes, so I agree on that. And when we started with Fusion and went out to show a couple of companies that there's AWS Amplify now interested in helping already with that. There's IBM StepThan that it picked a ton of companies that said that is a good idea. Let's do that and let's find this core specification. And that's also like the important thing is to get this core specification right, to not have too much. Like you don't want to throttle people and saying you have to implement this the exact same way, but it must be compatible so you can add tooling. Like as I said, like composition tooling from the guild has to work with the gateway from WunderGraph, and also the other way around, right? Then there should be analytics tooling. Like when we looked at Fusion, we also rethought how we do analytics, and that's why this isn't not in the core specification. We kind of have that as side notes that we use OpenTelemetry. We are also at the moment pushing for an OpenTelemetry semantic convention that is more rich than the current version of it, so we can create federated tracing but standardized, and there you can put the next tooling, and maybe you are using Elastic or Honeycomb or whatever, or even WunderGraph lets you just pipe in some telemetry from some other subgraph vendor. Then you get suddenly a complete new ecosystem where you can choose the best tooling for your use case as a customer, and also you are not siloed into a certain vendor. So that means you never be afraid that you cannot get out of the ecosystem at the end of the day if it doesn't fit your needs. And I think that is having this choice is important. That's actually what exists when you look at the typical API gateways that we have around for REST.
Yeah, no, that's great, and I can totally relate. You know, two things that immediately come to my mind when you talk about OTel and standardization, for example. In the GraphQL ecosystem, you can say that GraphQL.js is not the fastest implementation. Like you can do it faster in Go, you can do it faster in Rust or something, or maybe in Java. But the GraphQL.js ecosystem is just huge. And if you build something that is compatible with GraphQL.js, you immediately tap into a huge ecosystem. And that is also something I learned over the path of my career in the Go ecosystem. So I know you're deep on .NET, so maybe you have similar stories, but in the Go ecosystem, when you are a younger developer, you are kind of thrilled to explore how fast can you make Go. And everybody's like, oh, Go can do so many Go routines, and it can do millions of WebSockets, and it can be so fast and everything. And as a young Go developer, you look into things like there's packages like fast HTTP or other things, and they do all kinds of super cool tricks with buffers and real things, and those things are super cool, and you use them for a bit of time. And over the years, you get a bit older and you want to solve more customer-facing problems, and you want to code faster. It doesn't matter so much anymore to write the fastest code, because Go code is usually fast enough. And what you do when you mature a bit, you just use the net HTTP standard library, and that gives you CORS package, caching package, standardized clients and everything. And suddenly you have all these dependencies accessible to your tool belt that just work and they work together. And I think, coming back to with this long-winded story, I think in terms of GraphQL-Fusion, if we can standardize on this core, we can build a huge ecosystem of things that can actually work together. Like you have a telemetry stack, and it can work with any gateway, and you have a Fusion configuration, and it will actually work on different gateways by different vendors. And you can stack tools, like you can say, oh, I have these things, I do that with Chili, but actually I can put that into another Fusion graph with WunderGraph or something from the guild. And that's where I see the power. And after all, if we have a bigger ecosystem, you know how hard it is to convince people to use the WunderGraph way of composing APIs. But if we can build that huge ecosystem with variety of tooling, I think it's much easier to create such a new market and tell people, like, it's kind of like an OpenID Connect certification. If you can say you have an OIDC certified OAuth 2 server or something, it means something. People know what you have.
Yeah, and it's also like from a customer perspective. If I know I'm logged in, like I mean, I'm German, right? But if I opt into something like SAP, I know I never get out there, right? So I have to think twice about it. But if I had a standardized way and I could opt into one thing, and I know they are following the Fusion spec, and that means, like, if that doesn't fit my size, my scaling demands, or whatever need I have, I can go to this other company, or I can go to AWS because that is better to me. Then it also lets you, I think it makes you more likely to tap into that technology, because you know you're not imprisoned into a single company or whatever, right? Because like, you have the choice. And maybe it's not that you fully want to change your tools. Maybe it's just this one thing that you want to add. One of the favorite things here I have as an example, maybe you start with WunderGraph, and you're fully happy with everything that you guys have and with the composition, but you want to have this WAF interface in front of that for GraphQL. And maybe that interface is just with the Fusion telemetry and everything. And now you have this security gateway for GraphQL in front of WunderGraph, and get into WunderGraph also all the telemetry of there, because it's standardized. That's where we want to go with that.
Yeah. No, that makes total sense. It also reminds me, how familiar are you with Kubernetes?
Yes, I had my fair share of Kubernetes.
Okay.
But no, we are running, like, our services are running on Kubernetes.
Okay.
I love the way you answered that.
How are you familiar with? Yeah. Okay. No. But what I wanted to say is, Kubernetes has constructs like the ingress.
Yeah.
And then you have different implementations of the ingress. And ingress is very vague, and I don't want to go into a discussion, is that good? But for example, the ingress, it allows different companies to implement an ingress and then use weird annotations and other things, and just mentioning as a similarity.
But it's also like, this is good. You have like these Helm charts and stuff like that, and you can compose essentially how you want to configure Kubernetes, right? And this is, if you know what you're doing, it's actually good with Kubernetes. If not, it can go wrong.
When you say Helm charts, it reminds me of lengthy debugging sessions to figure out indentation.
Yes. As I said, I had my fair share of Kubernetes. And like, it's super good. And if you have someone in the team that knows what he or she is doing, then it's super good.
Yeah. We have someone who can just set up something over the weekend and magically it will work. It's good to have such people. Coming back to GraphQL, one of my pet peeves about Federation, and I'm a fan of Federation, but I can have pet peeves as well. And Fusion does the same thing. And I'm like, is that actually good? Is both put selection sets into strings.
Yeah. So to be honest, like we did that with stitching already. Like before Federation even was a thing, we did that. But it's like it's semantical, right? In GraphQL, you have semantical scalars. And if you have a semantical scalars like email or so, then this is not just a string. Like it's in the GraphQL syntax, it's a string. Sure, that's a serialized way, but it's actually not a string at runtime. So, how else do you want? You cannot really serialize it any other way. And by putting semantics into that, it's not the string. Like it parses, right? The moment you parse the whole document, it gives you already semantical errors on that.
Yeah, that's great. The only thing is,
so I kind of there are two things to it, right? To have these strings on a gateway level is okay, and where we have it mainly is on the gateway level. There is also a way to use it on a subgraph level in Fusion, but in Fusion we have embraced actually more the schema coordinates in many things, where we semantically want to point to things, and but it's also a string, right? A simpler annotation that you have. Schema coordinates, if you don't know what it is, it's a spec draft at the moment in the GraphQL working group, which allows you to point to any type system member that you have there. There's a standardized way soon to do that, and we are leveraging that also in Fusion.
Can you show us what that is? Sounds interesting.
I don't know if that.
And what problem does it solve? Schema. You said schema
coordinates. So you can point to things in. You can point to things in your SDL, and by doing that, for instance, what we do in Fusion is you can, for instance, mark an argument and say this argument actually is semantically the same than the field. For instance, this ID argument is semantically the same than the ID of the product object type. And if we know these two things, we already know, okay, if you use this field and put an ID in here, and this returns, for instance, a product, then we know, okay, you can basically use this field ID as a key to fetch the product. And by that, you automatically have what you also do kind of in Federation. You have semantically inferred an entity fetcher.
So you're saying there's a directive where I can link an input of a field to the response so that a gateway can understand the input ID is the response ID.
You basically add semantics because, like, if you look at the schema and you try to reason about the schema, you need semantics, and these semantics cannot be easily inferred because I could, for instance, there could be typos, there could be other things, there could also be, like, I have a field that is called product, has an argument called ID, but this ID is not the product ID, it's actually the address ID or whatever, and it returns a product. So we couldn't just infer that as a fetcher for product without more semantical indication. And if you annotate that with a schema coordinate and say, actually, this ID is the same than the output field on product, then we know, okay, if you pass in this ID, then it's actually getting product. We know that's a key to fetch product. That
So
is,
an alternative to this could be, but I don't want to go too deep because I guess there's lots of discussion in the working group that you could also say the type of the input argument is product.id.
Yeah, that is actually a schema coordinate.
Yeah, okay, just in another syntax.
Yeah, no, that's an actual that is a schema coordinate as specified.
Okay. So I didn't know.
Yeah, that is that's what I say. You can use field syntax, but you can also use schema coordinates. And schema coordinate is, for instance, if you want to point to an argument, you say product dot field name, then braces, and in the braces you specify the argument and then have a colon in there. That's how you refer to a single argument, and that's the schema coordinate specification draft. It's already implemented in Hot Chocolate and also in the reference implementation in GraphQL.js. Because when you set GraphQL.js as a good standard thing, what many people don't know, GraphQL.js is the standard implementation, and that's why it's also not the fastest implementation, because it's very close implemented to the spec. You could actually, and the guild is working on something like that, if you implemented a different GraphQL core in JavaScript, you could actually make it super fast. I remember when we were tuning our GraphQL server back then, there was this one GraphQL framework called Benzene back then. I don't know if you know that. But it was super fast in GraphQL. Like it rivaled the Go implementations back then.
Yeah.
So just to note, so not to make GraphQL.js that bad on the speed side. It's just so we keep the algorithms in the reference implementation actually very close to the spec, and the spec favors more simple algorithms, so it's easier to implement. But there is a section, a note in the GraphQL specification that you can always implement a faster algorithm if you have the same output, right?
Yeah. Yeah, that makes sense. Also reminds me, so I'm a maintainer of GraphQL Go tools, which is an implementation of GraphQL in Go. And one thing we did is, are you familiar with the term string inlining?
Yeah.
So when we parse a GraphQL document, what we actually do is we have a huge buffer, and we create an AST tree, and this AST is just lists of nodes that are pre-allocated, and all the nodes do is they kind of have an enum, what they are, and a pointer into the buffer. So when you do something with such nodes, you're not doing anything with the actual nodes or with the data, or you're also not moving around data. You're just moving around or working on pointers. It is extremely dangerous to work with this. If you don't know what you're doing, it panics immediately. But we have thousands of tests, and if you do the right thing, then it's fast.
Yeah, we do something similar, but like on the byte level. So we implemented for our parser our own UTF-8 encoding, because we never allocate a string. So we take immediately the raw byte stream from the HTTP stream, and then we pass the JSON, escape it, and go into the query field, and also escape that to pass the GraphQL syntax and never allocate a single character.
Yeah.
And from that, like the complete parsing process is allocation free in Hot Chocolate. But yeah. I'm very familiar with these concepts.
It sounds like different languages and people with different experiences somehow come up with the same solution in the end.
It's always like it's always the same constraints you have. Like there's you don't want to allocate too much, because then this allocated memory has to be garbage collected, or you have to release it, or whatever. You have to care about it, and it's always best to not allocate.
Yeah. I have another question. Topic change. Very early in the discussion, you mentioned the word TSC.
Yeah.
You are a TSC.
Mhm.
What is a TSC? What is the role, the responsibility, and can you tell us a bit about what is currently? Is there any significant changes or movements happening in the GraphQL spec? Can we expect something?
Yeah, there are several huge improvements coming that we are working on. But let me just before I tell you about a couple of them, let me first line this out. So the GraphQL Foundation has something called the GraphQL Working Group, and the GraphQL Working Group is actually open to everyone. So everyone can join there and propose changes, discuss schema changes, and while you shouldn't just go in there and try to talk all the time, so you can come in there and maybe you do a couple of meetings where you just listen, and then you are kind of getting into the flow of this. But then you can participate. Everybody can participate. And the general rules that we have there is that we try to do decisions on a consensus level. That means we try in the group that is working on these things to have 100% consensus. And if there is not consensus, for instance, if Apollo is not happy with the feature, or Meta has problems with the thing that we want to introduce in GraphQL, then the feature might not be has some rough edges still, and we will work on that. And you can see that, for instance, with things like the defer spec and others. So while I say that is, so everybody can work on the GraphQL working group and do spec proposals and work on the specification. But then there is like the GraphQL TSC, and when like we have reached the level where we say, okay, this is a good thing, we want to have that in, and everybody agrees, then the TSC will kind of vote on that and make that formal. So the TSC is always when we have to do the final binding decision. That is what the GraphQL TSC does. But what the TSC is not supposed to do is basically keep everybody else out and work alone on a spec. So it's more like the binding legal decisions for the specification texts. That is what the TSC does. That means when we do the final draft of a specification, then the TSC will vote and review the spec and give this final approval. Other things that the TSC also does is decide on what the GraphQL Foundation technically takes on. So on which specifications do we want to work? Like, for instance, the GraphQL over HTTP spec, or like Fusion. Do we want to work on Fusion? That is where the GraphQL TSC will vote on. And the TSC is basically 10 people that are voted in by the TSC. So half of the TSC every 2 years is voted out. So basically, there's a vote by the other half of the TSC to vote in new TSCs. And everybody can also say, hey, I want to be a TSC. I want to spend countless evenings of my private time in the GraphQL Foundation working on spec text. Then you can do that. And typically, like the new voted in TSC members are typically from the GraphQL working group. Like if you have worked there a couple of months or years, then typically that's where the people are voted in from. And there's one chair that is not that we don't vote on, and that is Lee Byron. and he's one of the 3 guys who came up with GraphQL. There were Nick Schrock, Dan Schaffner, and Lee Byron. And Lee Byron is still like leading the efforts of the GraphQL Foundation and kind of
he's the immortal king.
Yeah, he's you know a big
yeah.
guy.
So he's the tiebreaker. Like Lee is very laid back, so he puts really the TSC in charge of all the things. But if there is a tiebreaker needed, that's basically where he would come in and then make a decision if there's a 5-5 vote. Never happened, to be honest.
The things that the TSC works on, decides and discusses, or what, is that public?
Not all. Like for instance, the TSC also decides on how we spend money in the community. Like there is like when you have a GraphQL project that maybe furthers the GraphQL adoption in itself, then you can file for funding from the GraphQL Foundation. And that's also what the TSC votes on, but these decisions are private. The TSC can only see that. But all technical aspects where no personal information are involved and things like that, they are open, yes.
Okay. Very interesting. Thanks for these insights.
And just a 10-minute warning. So we have 9 minutes left. So in the last 5 minutes, we'll be answering questions. But I didn't want to interrupt the flow. These are some great questions we're getting out here.
Yeah, and so the second aspect of I took much too long to explain the structure.
You're fine. You're fine.
But like what features are coming up? There are a couple of, like defer is something that many GraphQL implementations by now have draft implementations for that. There's a new approach coming soon that will let a lot of people do a lot of work in implementations of defer. But like that's one of the major features that is coming out. If you don't know what defer and stream is, it's a way to, in your query, mark parts that maybe incur a heavy load on the system, and you can basically tell the GraphQL server, if this section of your query is expensive, you can give that to me later. And by doing that, you kind of deprioritize things in your query. Or the stream directive is a way to say, okay, we have a list, maybe 100 items or whatever, and I want to stream it. And I also can tell the GraphQL server, basically, stream this list, but give me the first 5 items immediately, because then I can already display some data, and by the time the user scrolls, we get the other data in. That is the most or the biggest thing the GraphQL working group is working on, and took a lot of resources. There are other things, like there's a client-controlled nullability, which allows clients that write queries basically set error boundaries in the queries. Or you could also say you can change the nullability aspects of a query and say, okay, this query the server says is not null, but I know if there's an error, then you have this typical non-null propagation where fields are deleted upwards. And with client-controlled nullability, you can now put error boundaries in. So basically a question mark behind the field. And then this non-nullable field becomes nullable. That's one great...
it smells like relay.
It is. These ideas, like most of the spec ideas, actually are things that Facebook has for a long time. Like it's always, they just let us figure it out in the open how to do it, but they have solutions for these aspects for a long time. But sometimes relay, you mean the required directive, right?
Yeah.
You kind have to have everything nullable on your schema. And that loses a lot of expressiveness for your schema. So they had a solution for that, but it was not super well done. And client-controlled nullability tries to formalize that and have all the intent still in the schema, but then override or send the client expectations in the query. Yeah,
but client controlled indicates that's not on the server, it's on the client.
No, the client says what the expectation is. So I can say at the client, I don't want this to be non-nullable anymore. I want this to be nullable. And then the server, when it executes the query in the server, will actually say this field is now nullable. And then you have an error boundary at that point.
Okay, so the client can change the resolver behavior, kind of.
Yeah, kind of like more the value coercion level, right?
Yeah.
Where the resolver is the same, and then you have this part which is a value coercion algorithm that would then do something different and not propagate the error upwards.
That makes sense. Quick question on defer. Like you mentioned, I'm not sure if I got it right. Is there a new approach to defer, or the approach that was in the making for a couple of years?
So we had a draft, but like at some point, I, Rob, and Benji sat together and we poked a couple of holes into the concept, and it was very easy to DDoS the server with the current defer spec that originally was done. And there were other things like that we like, for instance, non-null propagation that didn't work over the current aspect. We always said, okay, if you have a patch, it's basically also a non-null boundary, because you cannot propagate an error upwards if you already sent the data down. And things like that we iterated on. I actually split off of this work at some point and worked a lot on Fusion, but that's where Benji and Rob did a lot of work, and also Yakov, to solve these issues, to don't have these null boundaries in the patches anymore and other things.
So how certain are you this is going to be it?
Yes, I think it's so what I read in the proposals looks really good. We will see. I will finally meet up with all the other TSCs and working group members at GraphQL-Conf, and I hope we have a lot of discussions there on finalizing this. So for us in Hot Chocolate, it's a lot of work to redo that, and we also have to redo that for the Fusion spec. But yeah, I think it looks now really good.
Nice. Because I intentionally refused to implement the last draft because I wasn't sure if it's going to end up in the spec, and it sounds like sometime in the future I can start implementing the new one.
Yeah, I talked to Yuri from the guild, and they also they refused it in yoga for a long time, because also on the, like, if you're living on the draft edge, you sometimes have to re-implement things a couple of times, and you also break your users. Like, we broke our users with the defer spec like 2 times because the draft text changed. But I mean, we also like disable these features by default and tell people you can already run the latest draft specs with Hot Chocolate, but it might be that next version the behavior changes. So know what it means to run draft specifications, but it's like with the browser.
I mean, it's a very interesting topic, especially for something like Fusion or WunderGraph or Federation, just because obviously in a microservice architecture, something can be slow. If you can defer that makes a lot of sense. But from an implementation perspective, it adds a lot of complexity. Like, you have a request, you generate a response, you shoot it back, quite simple. If you have that request and you divide it into patches or something, or however you do that, you now have a long-running operation. You need some sort of AST transformations to create patch resolvers or whatever you do to actually implement that, and it simply adds a lot of complexity, and depending on how you do it, it can make your resolver code much more, I would say, convoluted or complex, harder to read.
The resolver code not like your personal resolver code in your GraphQL server, not, but
in the gateway.
Our work is more difficult to writing the gateway.
Guys, we are at time. I am so sorry to interrupt the conversation.
No,
Michael, it was fantastic. One question though that I saw in the audience: why did you come up with the name Hot Chocolate?
Okay.
Last question, and then we're good.
Yeah, it's an often asked question. So, like when we created the GraphQL implementation in .NET, we were thinking about name. If you look into our repository and look on the first commit, it actually was not Hot Chocolate. But we didn't know a name, and we didn't want to call it nGraphQL or GraphQL.net or whatever. And we always liked the way JavaScript libraries do it. Just throw something random at the wall. And we were actually standing in Starbucks, and my son, me and my brother, was starting this thing. And my son came up and said, "I want a hot chocolate." And then my brother said, "Let's just call it Hot Chocolate." And since then, every product we build, actually, we go to the Starbucks menu, we pick one thing, and like for instance, our GraphQL IDE is called Banana Cake Pop. You can go to Starbucks in the US and buy a birthday cake pop. That's where these names come from.
So it's just Starbucks.
Yeah, it's Starbucks. It's basically, if we have a new product, we go to the Starbucks menus, choose the most ridiculous name they have there. Like our GraphQL client, for instance, is called Strawberry Shake. It's also...
Be careful that they don't sue you.
Yeah, it's a bit
dangerous.
The name.
You live dangerous.
You said ridiculous name though. My sister's order is an iced caramel frappuccino with 2 shots espresso and 1 shot of almond milk. Do you think you'll name something like that in the near future?
Yeah, you know our console tooling where you compose graphs with is called Barista. It's a guy that makes.
Of course.
I love that. Well, Michael, thank you again so much. I love the naming conventions, and it was an honor, to have you on for our launch week. We'll see you at GraphQL-Conf, right?
Yes.
Okay, amazing. Thank you again,
Ciao,
Michael.
Michael.
Thank you, Jens.
Goodbye.